cosine omega t minus cosine omega n t. Okay? And note that this cosine omega t minus cosine omega n t can be expressed by 2 times, you remember the cosine alpha minus cosine beta can be expressed by sine 1/2 alpha plus 1/2 beta, and then something 1/2 alpha minus 1/2 beta. You see, long time over you learned elementary trigonometry functions. So I can write this as a sine omega n minus omega over 2 t sine plus omega over 2 t, and this is the rate of oscillation, how often the vibratory system oscillates. So if omega n minus omega is small, meaning that omega, the excitation frequency is getting too close to the natural frequency, then this is going to be smaller and smaller, and this is going to be much larger than omega n minus omega divided by 2. Okay, so mathematically meaning that this term is very slowly fluctuating, and this term is very fastly fluctuating. Adding this together will give me beating, and beating frequency is defined as this, omega n minus omega is the beating frequency. Okay? At resonance, however, okay, at resonance, meaning that omega n is equal to omega, meaning that I am exciting the vibratory system. Oh, you can't. I thought you were. There are 5 or 6 students who are absent. And were you here at the last? Were you here at the last lecture? Not here at the last lecture. You was here. Okay, so try to get us. At the resonance, omega equal, I'm exciting the system with natural frequency. And what happened? Using this. Welcome. The response is 0. Sine 0 is 0. Mathematics shows us the result that is not consistent with what we can imagine or what we can see physically. Right? It's nonsense, right? What we physically see is what? Right? Oscillated response is getting bigger and bigger, like this. This is what we saw. But this equation only shows that omega n equal omega is 0. Why? Because this solution is not, one could say, simply saying that this solution is not valid at omega equal omega n. Then the student will ask me why. If you see the text, there is some interesting argument about this question. And the author said, because this solution does not satisfy with what we can observe at omega equal omega n, and he also said this is not particular solution we can see at omega equal omega n. Therefore, we have to assume that the particular solution has the form, for example, t multiplied sine omega t, something like that, omega n t, something like that. And here we can obtain this solution. But doesn't matter whether we can obtain the solution by assuming this type of particular solution, but we can at least know that from this expression, our approach to omega 0, the magnitude will blow up bigger and bigger, and the frequency omega will approach to omega n. And we cannot determine the magnitude. We all know the magnitude will go up. How much? Go to infinity. Okay? So actually this expression essentially extrapolates or shows what we will have at the rest. The argument he showed in the text is sort of supporting material that it can help you to understand what's going to happen at the rest of mathematically. Okay? What if we have damping? Now we have a damping. See? The governing equation is changed to mx double dot plus cx dot plus kx equal f0 cosine omega t. And then if I divide this by m, then I will get c over m. Then I can write 2 zeta omega n x dot. Why? Because c over m is equal to and this is damping ratio, right? And we know that the CR is 2 square root km from our vocabulary book. And noting also that omega n squared is equal to k over m, and then I can write it